Well, congratulations to us. We finally have a fully functioning Tetris game. We have the pieces, we have the line clearing, and we have the game over condition. The only thing we're missing is the points over here. And I want to add the points in last because I want that to be tied to the physics that we're going to put in this episode. So in standard Tetris, like we have in front of us, we have pieces falling at a constant rate. Now, of course, we know they don't do that in the real world when you're playing Tetris blocks in the real world with your telekinetic powers or whatever. In the real world, things fall with an acceleration toward the surface of the Earth, and then they start to not accelerate as fast thanks to the drag force. So what we're going to put in today is an acceleration downward and a drag force pointing upward. So this is a pretty major revision to the code. So I think what I'm going to do is copy this and then make a new version just so that we've got this working version archived. Let's go over to Let's Code Physics. Create new program, Aero Tetris with Physics. There we go. Control A, Control V. All right. Double check, make sure this works, that I didn't lose anything in the copy paste. All right, I'm having an issue with my I-beam for some reason. Let's go down and fix that. I think what I need to do, I think I need to get rid of this half, maybe? I don't know. I'll keep an eye out for that on the I-beam and figure it out as we go. Okay, so we need to change the rate that this falls down by. So let's think about it this way. When we drop these things, we move them down by 1. So where do we change the active piece position? So we say while falling, rate animation rate for piece, square, inactive piece, etc., etc. Okay, here we go. Here's where we decrease the thing. So now what I want to do is change this into a dy. And then we're going to change this one into a dy. Okay, before we can update the active piece position, we have to update active piece velocity. So, actually, let's do this. Excuse me. Brian, take out that last little glitch. Okay, what we're going to do, we're going to take this if falling, place it up here, tab these comments in. So I need to take active piece dot pos dot, excuse me, not pos, dot velocity dot y plus equals, we'll call this force. Okay, so I'm going to need to define a couple things. I'm going to need to define active piece velocity and force. So when these folks start out, active piece needs a velocity of vector 0, 0, 0. I could get away with just calling it the y with just keeping track of the y component because I don't have a velocity in the x and in the z. But you never know, it might be fun to add in, a headwind or something. I don't want to not include that functionality already. Okay, so we've got those two. Now I need to calculate the force, right? So I need to calculate force on the active piece. Okay, so the force is going to be the thing's mass times the gravitational field. Actually, I guess I could just call this the weight. Oh no, I do have to keep those separate because I'll need to update that over here. So I'll say force equals mass times gravity times vector 0, comma, -1, comma, 0. Very good. So I've got mass, gravity, 0, -1, 0. Good. Plus the drag force. So I need the drag force, or drag coefficient, times the, let's see, let's do this like the traditional, let's do this like the v squared drag force. So we'll have I guess I don't necessarily need a 1/2, that doesn't really matter. The drag force times the width of the active piece, active underscore piece dot width, times the magnitude of the active piece dot velocity squared. Then I want that to point upward. Okay, so I put in a bunch of stuff here. Let's visualize this. So what you have going on is you have your active piece here. and it is falling downward. What that means is that it is meeting air particles that in a relative sense are traveling upward against it. And so the rougher the thing is, the higher the drag coefficient is, the more drag force you're going to get. And then the wider it is, the more drag force you're going to get. Because if I were to rotate this piece like this, it would have less air molecules hitting it, right? So that's why we have the width here. And then, of course, the faster that the thing falls, the more drag force is going to experience. So that's why we've got the magnitude of the velocity right here. And we're squaring it just like in the regular drag force equation. You could change it to the first power, make it more of a damping force. They're both resistive forces. It'll be the same kind of thing. And then the drag force is always going to point upward because the thing is always falling downward. I don't think we're going to do projectile motion Tetris, although that might not be a bad idea. Okay, so I'll need to define those things above. Let me just copy and paste this so I remember everything it is that I need. Copy. And let's see. I'll need to define those. Let's define those up here because I'm going to want to change those later. Okay, so first I need a mass. Let's start everything out equal to 1 just to make it simple. We'll adjust them if and when we need to. Drag coefficient, usually want that to start out small. Let's call that 0. Actually, let's start that with a 0, just so I can test things with just gravity for a little bit here. Okay, so we've got the force here. So I've got my force calculated. Now I need active piece.vel. Oh, except I made those vectors, right? So I might as well. So I should just make that a vector there. And we'll say divided by the mass times dt. So I also need to define my time step. Animation rate equals 3, dt equals 0.1. Okay, so this should have the same effect of causing these pieces to fall. First, I calculate a force that is mostly downward. Then I update the thing's velocity, and then I move the thing downward. Active piece of pos.y minus equals. Oh, right. I need to let's see. I don't need to call that a dy. I can call that active piece.velocity.y times dt, and this should not be a negative anymore because this is already going to be a negative from this negative up here. So let's see. Although no, I can do that. That's fine. I was thinking I have the same dy. Actually, yeah, that's better programming practice. Let's do that. Let's calculate a dy over here, and then I don't have to have it calculating this thing over and over again. I mean, it's only a little bit of computer savings, but it's a game that it makes a difference. Okay, now what I need to do is test this to see whether my checks for whether the thing stops actually works. Okay, so it is accelerating downward. It is checking for pieces underneath it. I can still rotate. I can still move left and right. Okay, it still managed to come to a stop there. I kind of like how the animation rate is slow enough that you can see it falling by steps. I could increase the animation rate so that it's not quite so choppy, but I kind of like that. I feel like that might help students think about what they're doing with, think about what the animation is doing. It's apparently able to check beneath it plenty well. Let's see. Let me just make sure that that's working the way I think it will. So we need to check for whether the thing beneath it is visible. If grid index, if piece. Okay, if piece is less than or equal to piece square height. Okay, so it's able to check against that just fine. Let's see if I can... I can't rotate my I-beam. Okay, so I have done something to break the I-beam. I'm pressing the up arrow key and it won't rotate for me. So I will need to check on that. I suspect I goofed with the position of it. Let me just see something here. Okay, so I've got the horizontal position fixed. I must have something wrong with the vertical. For some reason, not letting me rotate the thing. All right, I'll check on that off camera. Okay, let's see if it will let me fall into this gap here. If it lets me fall into this gap, then I think I'm okay. I think that this is working. I just need to fine-tune the numbers. Okay, cool. So apart from the issue with the I-beam, I think this is fine. I will work off camera to fine-tune the numbers on this thing and figure out what in the world's going on with the eyepiece, which means the next time we play this, it'll be time for gamification and we'll have some points and such. So as always, thank you so much for watching. I will see you next time. Bye-bye.